In this video, we are going to also use Green's theorem, but this time integration is over half of a circle, so we will get to review polar coordinates. Isn't that fun? Let's go. Okay, so we've got 4y dx minus 8x dy. Now the curve is just a half of a circle. It looks like the radius of it is just 1. And first of all, we are going to, well, it says we're going to start at negative 1, 0. So we're going to start right here. Then we're going to go along a semicircle to 1, 0. So to here. So we're going to go here first. So this is what we do. And then we're going to come back from 1, 0 back to negative 1, 0. So we're going to go here. Okay, so immediately you could notice that the orientation here is actually clockwise, not counterclockwise. And so what that means is that our answer is going to be negative of what it would have been if it was counterclockwise. Okay, so let's see if we can set this up. So this is going to be double integral over the region enclosed by this thing. So let's just call it D. So this is D. Okay, what are we going to integrate? So P is the dx part, right? So P is 4y. And then Q, now this is very important. Q is going to include this negative, but because it's supposed to be P dx plus Q dy. So this is going to be like plus minus 8x. So be very careful if there is a minus here. That is actually part of Q. So let's compute P with respect to y, which is just 4. And q with respect to x, which is just negative 8. So what happens here? So we do q with respect to x, which is negative 8, subtract p with respect to y, which is 4. And then we are integrating over this half of a circle, right? Now, this is going to be correct if it were counterclockwise, but because it is clockwise, we are going to attach a minus here. So this is actually a double integral. This is negative 12, but it'll be positive 12. Okay, so we are going to go ahead and just put 12 over here. Now, this is a trick that I love a lot. So whenever you're integrating a number, you can always pull the number out of the integral, and then you are just going to be integrating 1. Okay, so it's like integrating double integral of 1. What it is just the area of the region. So area of D. And in this case, D is very simple, right? It's only half of a circle. And hopefully you know that the area of a circle is pi r squared. So for me, this is going to be pi. My radius is 1. And that would have been it, but it's a half of a circle. So that's just going to be 1/2. So looks like the answer will be 6 pi. Let's check that out here and see. Okay. Oops, he did not like 12. Why not? Oh, because it wanted us to connect this to polar coordinates. Ah, okay. So here is why this would not be correct. So I hope you remember, if you are to switch this, so if this was dy dx, the 12 would have been correct, but because they want to switch us to polar, then it's going to be 12, and there is something in polar that people forget, and I hope you don't forget it. I call it the pirate. What does the pirate say? Pirate says R. So don't forget the pirate, meaning an extra R that has to be there that I did not put. Okay, so if I did put 12R, that would have been right. Okay, now let's just set up the limits. Not that we need them because we already have the answer, but why not just extra practice with polar coordinates. So how do we set up the limits over this? Well, it's just a little half a circle here, right? So here is what we do first. So first we take like a certain theta, and fix it. Okay, so imagine that theta is fixed. Theta is fixed. R is going to be the distance from the origin to the point on this line segment. So it's going to go from here all the way up to here. So this is how it goes, from 0 to 1, because the radius of the circle is 1. So what that means is that the R limits are 0 to 1. Okay, now how about the theta limit? So now look at theta. Theta would go from over here. Theta is the angle with the positive x-axis. So it's just going to go like that, right? So it's going to go from 0 to pi because it's the top half of a circle. Now, just to compute it real quick and just to verify that we would get 6 pi, even though we already know it. So this is going to be 0 to pi. This is 0 to 1. And the integral does not have a theta. So this is a splittable integral. And this is just 12 RdR from 0 to 1. So this will be pi. And then this would be 6r squared from 0 to 1. So that's just 6 pi, which is the same thing we got. So we are good.